So in this video, we will talk about how SD-WAN can or is potentially sunsetting MPLS and VPLS. Okay, so before we head there, let's just talk about what benefits did MPLS and VPLS provided service providers or the large enterprise customers. MPLS had the ability to do network segmentation. So you built one network, you called it MPLS, or you enabled MPLS, and that gave you the ability to do segmentation. And some people also call it virtualization, but segmentation provided you network security while the packets are in transit. So you have customer one, and he's got a 1.1 network. He connects to a shared core. That could be a service provider core or his own private core, which is MPLS. And he's able to get this L3 10.1.1 talking to L3 10.2.2, right? That's L3 communication or routing happening between two different subnets. MPLS also provided the fact that you can have different customers do exactly the same thing. Give them L3 connectivity, exactly the same subnet. Connect them to the exact same infrastructure core, and they'll get an L3 connectivity to their other side. So this is one core allowing you to route between overlapping addresses, and typically it's like if you don't even have overlapping, some of the enterprise customers require you to do segmentation on the core or as much as you can in the transit network, and this is a transit network. So this is what MPLS provided you, and then if you have a scenario where you want to extend your layer 2, so you would enable VPLS. And that's what VPLS allowed you to do, is you take customer one's L2, let's just say 10.3, connect to the same core and bring it on the other side of the world or the country, the same subnet, basically extending your subnet using VPLS. So here you go, you've got a pseudo wire connection. Here you got an L3 connection, right? So MPLS and VPLS allowed you to do that. And on the similar note, you have exactly the same customer who wants to do the same with L2 using the same subnet, and doesn't have to be. I'm just giving you the benefit of what MPLS VPLS provided, and he would be able to get or extend his subnet anywhere where the MPLS VPLS network goes. So here you can see the obvious benefit of MPLS VPLS. With one single infrastructure, you're extending, you're having connectivity routing between your different sites, overlapping addresses, and yet this guy keeps everything segregated, and it provided a lot of flexibility, not only from connectivity perspective, but also from a QoS perspective. So if you want your traffic to be segregated, you have multiple flows, you can implement QoS in the core to make sure that that particular traffic gets preference. So if you have private core, you can actually build and implement QoSs QoS implementation or policies for that particular traffic. Now, that having said or illustrating how MPLS, VPLS networks provided this connectivity, this architecture, how does this relate to SD-WAN? SD-WAN actually gives you exactly the same capability, and in fact more, because SD-WAN, one point that I wanted to mention is that for a customer like customer 1 and customer 2, if they want redundancy, if this is their own core or they have service provider, they would want another core or another service provider for redundancy purposes, right? And see how that complicates their infrastructure or their architecture from a WAN perspective. You got redundancy from ISP1 and ISP2, right? You got redundant connections, and I've got a video on SD-WAN and in terms of what problems it solves that MPLS couldn't. And if you have core issues in the MPLS, your link is still up and you're still routing to the MPLS, but your packet is getting dropped here or here. Complicated problem that was solved in various ways. And SD-WAN comes along and it says, well, I'll give you, so here you've got two transports. An MPLS network from an ISP is a expensive proposition because they'll charge you a lot of money to give you this infrastructure, and it's costly. MPLS circuits are costly. So SD-WAN becoming popular is the reason for that is basically now you're transport agnostic. So transport agnostic architecture or WAN architecture basically gives you the fact that now I don't care what my WAN is. I have an internet connection, which pretty much everybody has nowadays. I can spell internet. I have an internet connection as a transport. It's a bad cloud. Internet and LTE, or a second internet for that matter, right? You have the same customer 1 coming in, connecting to the internet, connecting to the LTE for redundancy or /internet, another internet connections which are cheaper, and is now able to go from site 1 to site 2 with his routing. So he's got this network, he wants to connect on the other side, and he can do that over the internet using SD-WAN technology. Why? Because SD-WAN enables you to do overlays. So he's got this SD-WAN device connected here and here, and this SD-WAN kind of creates an overlay between the two sites, right? It creates an overlay. An overlay could be a GRE IPsec encryption or just an IPsec tunnel. Let's just say tunnel. And therefore now you can route between the two sites. And guess what? If this is an ISP, and this is an ISP, which it is, in these WAN transports, and you have a customer 1 and you have a customer 2, let's choose a different color for customer 2. who wants to do exactly the same, which is the same subnet, comes into the internet, goes to wherever he wants to go, connects to his network on the other side, overlapping. What will happen is with the SD-WAN devices sitting, you're creating overlays. So there is no routing issue on the core transport. Transport is completely agnostic of what's happening because you're encapsulating everything. So now you can achieve the same thing at L3 level, L3 connectivity between different subnets, but now SD-WAN solution providers are also coming out with features that lets you do, let's see if I can choose colors, L2. So if customer 1 has an L2 connectivity requirement, connects to the internet, and he wants to extend 10.3, there you go. So you're now using the internet and extending your layer 2 subnet using the internet just by putting this SD-WAN solution on the edges, and you're going transport agnostic. This could be internet, this could be MPLS, this could be LTE, this could be anything. You don't care what this transport is anymore. You've got an overlay network that's encrypting your packet, your traffic at wire speed and providing you security and routing, and now even L2. So you got this exact architecture that you used MPLS, VPLS for. You're achieving those goals by SD-WAN solutions out there. So this is taking, obviously the service provider takes forever to transform because of the operational overhead, because they got thousands of customers connected to their infrastructure. Moving to an SD-WAN is just not as forward. It's an operational nightmare more than an architectural or technology shift. For other customers, small, medium, large enterprise customers, they can make these changes to go towards SD-WAN as a solution, and having two popular transports that are now being used, which is LTE and internet, as their redundant connectivity solutions. And obviously you have, you can keep your infrastructure, existing transport WAN infrastructure as MPLS until you make this shift, or until you migrate to this transport network. But this is where the WAN architecture is moving towards, is you use multiple core architectures or networks for redundancy, and your SD-WAN solution would automatically choose solving the QoS problem. If internet is the connection that you have from the internet service provider is having an issue, this connection would automatically switch to an LTE based on your policies, based on your definitions, and whatever you want to decide to do with that traffic. So that gives you the QoS. So you don't have to worry about implementing QoS in the core. And it also gives you the transport agnostic architecture, where you don't really care. The internet connection comes in pretty quickly on any given site, unless it's a remote site somewhere in the desert. But typically getting an MPLS connection somewhere takes 90 days or more. So that's what SD-WAN is providing, and it's essentially technically or architecturally replacing MPLS and VPLS. When I was exploring SD-WAN, my biggest concern was that it won't replace VPLS, but now I do see customers or SD-WAN solutions coming out with L2 extensions. So if you ask, I'll let you know who those are. But once you have SD-WAN with L2 extensions where you can actually have the same subnet extended over any transport in the network, you don't need MPLS or VPLS anymore. So that's really exciting, and obviously operationally it's a nightmare to implement MPLS and troubleshoot MPLS versus the visibility and automation that you get in SD-WAN is phenomenal. And there's technically and architecturally, it's just a no-brainer to go towards SD-WAN, whether it's L2 or L3. So that's pretty exciting that now we have an L2 and an L3 solution from an SD-WAN solution providers. Hope this helps.